Good afternoon, class. I hope everybody's doing fantastic. My name is Alvaro Leal, and I'm your William Baptist University Advanced College professor. And today we're going to be looking at quiz number 4, which continues on the thoughts of linear equations and a bit of quadratics. So the first question, let's go ahead and read it. It says, graph the equation by determining the missing values needed to plot the ordered pairs. We got y plus x equals 4. And then they give you bits of the points. They give you the x components of the point. So what we do is we subtract x from both sides, so we get y is equal to 4 minus x. And so the next thing we want to do is we're going to start plotting these points. We're going to have x, we're going to have y. We're going to put 1 for x, so 4 minus 1, that's a 3. We're going to plug in a 4, 4 minus 4 is 0. And then we're going to plug in a 3, 4 minus 3 is 1. So those are all the values that we get by substituting 1, 4, and 3. Let's go ahead and put those values over here. This becomes 1, 3, 4, 0, and 3, 1. Okay? And so now what we need to do is we need to find a graph that has these values, 1, 3, 4, 0, and 3, 1. All right? So let's take a look at our graphs, and we see that, let's see, 1 and 3 up, yes. Then 4, 0, and 3, 1. So I'm looking at letter D as my answer. Letter D as my answer. Letter D as my answer. Okay, so you're going to do number 2. Remember, I do the odds, you do the evens. So let's continue. Let's go to the next one. Let's go to, okay, you do number 2. I'll do number 3. It says, for the points P and Q, find the coordinates of the midpoint of the segments PQ. All right, for this, let's go ahead and write a formula. The formula for a midpoint. The midpoint formula says that m is going to be x1 plus x2 over 2, and then y1 plus y2 over 2. So it's pretty much the average of the 2 points. So in question 3, we are given 2 points, right? We're given P and Q. P is 6, negative 4. And Q is negative 7, 7. So the first thing that I would recommend for you to do is label these points. This is x1, this is y1. This is x2, and this is y2. So after you label them, then it becomes really easy to know where these go, right? So your midpoint is going to be x1 is 6 plus x2 is negative 7 all over 2. Then your y component is going to be y1, which is negative 4, and y2 is 7 over 2. Remember, it's like the average. All right, so now that we do that, we got to do a little bit of math. 6 minus 7, that's a negative 1. So your midpoint is going to be negative 1 halves. Negative 4 plus 7 is 3 halves. So this would be answer choice D, right? Answer choice D. All right, you do number 4, I'll do number 5. So number 5 says, find the coordinates of the other endpoint of the segment given its midpoint in one endpoint. So this one, you have to work backwards. They give you the one in the middle. They give you one of the endpoints, but you're missing the other endpoint. So what we need to do is we need to reverse the process. You see how we got this? But it was the average of these two things. So this is what I'm going to do. I'm going to say, okay, x1 plus 10 over 2 has to equal to 13. Because they tell me that the midpoint is 13, 1, right? So this has to go here. And then y1 plus 5 over 2 has to equal to 1. You see? We're reversing the process. We're saying something plus something over 2 has to equal to 13. Something plus something over 2 has to equal to 1. So now we got to do the opposite. You know how over here we divided by 2 to get there? Now we're going to have to multiply by 2. That's the reverse of the process. We're going to have to multiply everything by 2. Everything by 2. So here the 2's cancel. And 2 times 13 is 26. Over here the 2's cancel. And then you're going to get 2 times 1 is 2. All right, and then we're going to subtract 10 from both sides on this one, and we're going to subtract 5 from both sides on this one. We're going to get x is equal to 16, and then over here we're going to get y is equal to negative 3. Okay, so your answer is 16, negative 3. So your final answer is 16, comma, negative 3, which would be answer choice D, right? Answer choice D. So this one you have to reverse the process. You have to multiply that side by 2 and this side by 2. Those 2's cancel, but this becomes a 26. These 2 cancel, but the 2 times 1 becomes a 2. Then you do the opposite. If you're adding 10, you subtract 10. If you're subtracting 10, you add 10. It's always the opposite. Don't think you're always subtracting. If this would have been x minus 10, then you would have to add 10 to both sides. Then whatever you get, that's your x element, that's your y element, and so your other endpoint. So endpoint number 2, right? Endpoint 2 would be 16, comma, negative 3. All right, you get to do number 6. I'll do number 7. It's another example just like this one. Another example just like this one. So let's go ahead and do it. Problem number 7. We got midpoint is negative 1, negative 8. One of the endpoints, we'll call it endpoint number 1, is 3, comma, negative 10. So what do we know? We know that the midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. So we have to reverse the process. We have to say, all right, that means that x1 plus 3 over 2 has to equal to that. It has to equal to negative 1. Also, y1 plus that over 2 has to equal to that. You see, this one goes here, and this one goes over here, and then this plus that over 2, and then this plus that over 2 is going to have to equal like that. Okay, now we have to reverse the process. We have to multiply by 2. We have to multiply by 2. So, of course, when you multiply by 2 here, these cancel, but not over here, right? x1 plus 3 equals negative 2. These cancel, but then you get y1 plus negative 10 is equal to negative 16. Okay, you always do the opposite. You see how we're doing plus 3? We're going to do minus 3, minus 3. So x1 is negative 5. Over here, you see how we have a minus 10? So we're going to add 10. We're going to do the opposite. Counter it. y1 is equal to negative 6 because I owe 16. I paid 10. I owe 6. All right, so the answer is going to be negative 5, comma, negative 6. Answer choice C, right? Answer choice. Where am I? Over here. Let me move this up a little bit. I'm on number 7. So the answer is answer choice C. Or am I doing a different one? I think I did number 6. Sorry, guys. For some reason, I did number 6. Well, one less for you to do. Okay, let me do number 7. Okay, good for you guys. Lucky you, I did number 6. Okay, number 7. That was number 6, guys, number 6. Number 7, let's go ahead and do it. We got the midpoint is -2, 1, and the endpoint, let's call it endpoint 1, and it's 3 comma 2. All right, so that means that x1 plus 3 over 2 has to equal to a -2, and y1 plus 2 over 2 has to equal to 1. And notice I'm getting this from here and this from there, okay? That's how I do it. Okay, now you gotta double everything so that you can cancel the 2 on the bottom. So x1 plus 3 equals -4, and then y1 plus 2 is equal to 2. Then we gotta counter it. If we're adding 3, we're gonna subtract 3. We gotta get rid of it. Okay, we're gonna counter this one by subtracting 2 as well. So y1 is equal to 0, okay? That means your final answer is -7, 0, or letter C. Letter C. All right, guys, so you get to do number 8. Let's go to number 9 now. Number 9 says determine whether the 3 points of the vertices are of a right triangle. So what I would recommend on this one is I would just plot the points. Okay, just plot the points. So let's go ahead and do number 9. Number 9, we have 1, 4. We got 7, 6. And we got 11, -6. Okay? So what I recommend is that you just plot these points. 1 to the right, 4 up. And then 7 to the right, 2, 3, 4, 5, 6, 7. And 6 up, 5, 6, 7, 6. And then 11, -6. So 8, 9, 10, 11. And then 1, 2, 3, 4, 5, 6. So -6. So this is going to be over here. All right. So for question 9, does this form a right triangle? We connect the dots. And we notice that it is a right triangle, okay? Now, if you want to be 100% sure that that's a right angle, then what you do is you find the slope of this and you find the slope of that. And if they're negative reciprocals of each other, then they are, it is a right angle. So let me show you how that's done. To find the slope of this line, you would do rise over run. So you would do x1, y1, x2, y2, okay? You would do 7 minus 4 over, I'm sorry, 6 minus 4, not 7 minus 4. 6 minus 4 is the y2 minus the y1. So the slope formula is y2 minus y1 over x2 minus x1. So it's 6 minus 4 over 7 minus 1. So the slope here is 2 over 6, also known as 1/3. So the slope, I'm sorry, went out of bounds there. Okay, so the slope is 1/6. So that means it rises 1, it runs, rises 1 and runs 3. Okay, that's the slope of this line, this one. What about the slope of this one? Okay, the slope of this one, let's call this one slope 1, this one slope 2. The slope of this one, now this would be your x1, your y1, this would be your x2, y2. So this would be -6 minus 6 over 11 minus 7. So your slope 2 would be -12. Remember, this is not 0. You owe 6, and then you owe 6 more. And then this is going to be 4. And this is the same thing as -3 over 1. Now, if these are reciprocal of each other's and negative reciprocal of each other's, they're perpendicular. Two lines are perpendicular if and only if, sorry, that's an N, if and only if the slopes are negative reciprocals of each other. I know this is very mathy, and you might be thinking, "Oh, Mr. Leal, we didn't have to do all of that. We could have just drawn the picture, and I can see that it's a right angle." But I mean, if somebody wanted to see, right, if slope 1 is equal to A over B, slope 2 is negative B over A, then they are perpendicular. And if they're perpendicular, if the lines are perpendicular, then they form a 90-degree angle at the intersection. Okay, I know this is a lot. Like, we really didn't have to go down this path. What I recommend when you do yours, just plot the points, and if it looks like a right angle, it's a right angle, okay? It's not, they're pretty simple to see that they're right angles. But if you want to prove that they're right angles, then you have to do the slope of the one line and slope of the other line and see if they're negative reciprocals of each other. A reciprocal means that you have to flip this number and it has to be this, but negatives, because one has to be going one direction and the other direction. Okay, you do number 10, I'll do number 11. And again, I'm not going to do the mathy part anymore. I'm just going to do the easy part, which is just plot the points, right? So we got the 0.6, negative 6. We got the 0.9, negative 6. We got the 0.91, okay? So we're going to just plot these points, okay? This 6 to the right, 1, 2, 3, 4, 5, 6. 6 down, 1, 2, 3, 4, 5, 6. And here's my first point, okay? This is the x-axis, this is the y-axis. And then we got 9, so 7, 8, 9, and then 6 down. And then we got 9, and then 1 up. Okay, for sure this is going to be a right angle. Look at that. It's a vertical line, for sure. A vertical line and a horizontal line form a right angle, for sure. This is a yes. Okay, and by the way, the other one was also a yes. I don't know if I said it at the end. Did I say the answer yes? Yeah, you were supposed to say yes, right? Letter A. I don't know if I said it. And so for number 11, it's a yes, letter A. Okay? Yes, letter A, in case you were wondering. And remember, if it doesn't look like a right angle, then it's not a right angle, okay? All right, let's go to number 13. Find the distance between the points P and Q and DPQ, right? All right, so we're gonna have to write a distance formula for this so that we know what we're doing. So the distance formula, distance between 2 points is D is equal to the square root of X, we'll say x2 minus x1 squared plus y2 minus y1 squared. And this comes from the Pythagorean theorem. From the Pythagorean theorem. Let me move this up a little bit this way so you can see everything. Okay, that's your formula. We're going to use this formula to find the distance between 2 points. All right, so on question 13, let me move it up a little bit because it might be out of reach, okay? So question 13, we got P is -6, -1, and Q is 6, 3. Okay? Now, so you can have a visual representation of this. We can use something called GeoGebra real quick. Let's go to GeoGebra. I hope I have it. I don't know if I have it. No, I don't have it. Let me go ahead and get it real quick. Where are you, GeoGebra? There you are. Okay, can you see it? No? All right. So let's go to GeoGebra. And this is geogebra.org/calculator. If you put that, you will get this really nice thing. So what I would recommend is you put the 2 points, -6, comma, -1, and enter. Then you do, and it doesn't matter if it's called A or P or Q. It's not going to matter, okay? Then it's going to be 6, comma, 3. Okay, you get your second point. Do you notice that we have the 2 points right here? All right, now what we can do is we can go to Tools, and let's build a segment, okay? Let's build a segment. So from here to there. Okay, so we're trying to figure out the distance from here to there. All right, now what I'm going to tell you is this, that if you use the Pythagorean theorem, you can get this. So watch, this is the trick. Get a point and see how this goes up right here. Just put it right there. You see, it's horizontally this way and vertically this way. Straight up this way and then straight this way, okay? Now we can create a this. Of course, guys, you could always do this. Get the length by just clicking these two, right? Look at that. That gives you the answer. But that's kind of cheating, right? We don't want to do that. But it's good to know the answer. We'll work our way there. Okay. Now what I'm going to do is I'm going to build a segment so you can see what is going on. You see this? I just built a right triangle. And the Pythagorean theorem says that this squared plus this squared is going to equal to this squared. Okay? So notice this distance right here. If I measure this distance from here to here, it's obviously easy to count. It's 4, right? And from here to here is easy to count. You can just count them with your fingers. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you see how this is 4, and you see how that's 12, okay? So that's basically what we have. So if we go back to our worksheet, we have a right triangle that this is 4 and this is 12. All right? So what we're trying to do is we're trying to find this distance over here. We'll call it C. So we got to make sure that, let's go back to scene 2. All right, so does everybody see what we're trying to do? This, when they ask you for the distance, this is what we're calculating. We're calculating C. Okay? So when we're applying this formula, we're actually doing the Pythagorean theorem. Do you see that? Because what does the Pythagorean theorem say? The Pythagorean theorem says the following, that C squared is equal to A squared plus B squared, okay? That means that C is equal to the square root of A, which is 4 squared, plus B, which is 12 squared. And so if we square these numbers, I'm going to get 144 plus 16 is going to be, what is that? That's 150, 160, right? Okay? And notice that there are no answers there that says the square root of 160 for number 13. Do you notice that? None of them say square root of 160. So you're probably wondering, what is going on, Mr. Leal? How come there's no square root of 160? Well, I'll show you why. You're going to have to think of all the perfect squares that go in there to simplify. We have to simplify. Simplify, sorry. So how do you simplify? You take out all the perfect squares. So what perfect square can I see there? Well, I can see that it's the square root of 4 times times 4, right? 4 times 4, that's 16 times 10, okay? But 4 times 4 times 10 is the same thing as, you can split this up, the square root of 16 and the square root of 10. So C is going to be 4 square root of 10. And now you notice that letter B is the answer, okay? Letter B, the distance. The distance is letter B. Okay? Now, what if we didn't have GeoGebra? What if we didn't have, how would we do this problem? Well, the way you're supposed to do this problem is you're supposed to label these like x1, y1, x2, y2. And then you're supposed to just use this formula over here. You're supposed to say, okay, x2, well, that's a 6. Then x1, that's a negative 6. It's going to be minus a negative 6 squared plus, and then it's y2, well, that's a 3 minus a y1, which is minus a negative 1, which is squared, right? So this is going to be 12 squared plus, because two negatives make a positive, right? So 6 plus 6 is 12. And then two negatives make a positive, so 3 plus 1 is 4. And notice we're back to that. Look at that. Don't they look exactly the same? We're back to that. So it's a square root of 160. And again, now, guys, you could just take your calculator at this moment and say, oh, you know what? Let me do the square root of 160. You could just take your calculator and say 160 second square root. And you see how we get 12.649? So if I pop this into my calculator, I get 12.649. All right? And then I go answer choice by answer choice and try it. So I'm going to try letter B. Look at this. Letter B is 4 square root of 10. So what I'm going to do is I'm going to clear, and I'm going to go 4 times, well, let's clear. We're going to do 10 square root, right, times 10. So we have to do, wait. We're going to do 10 second square root. What is going on? That is correct, right? Times 10. So 31.16. I don't know how I got that other number. 160 second square root. Oh, I'm supposed to be multiplying by 4. I'm sorry, my mistake. I was thinking, what is going on? Okay, so you're going to do 10 second square root and then times 4. I don't know why I was multiplying by 10. Okay, notice how this ends up being 12.649. So all this time, if you recall, when we looked at the picture over here, do you remember this? See how it said 12.649? You can just go and match it to whatever answer you have there. That'll be another way to get the answer. Okay? So 12.649, 12.649. So I'm showing you like 3 different ways to get the answer. Okay? All right, I'll do number 15. Because the more we do, the better, right? Let's take a look at number 15. And this time, I'm just going to use the formula, all right? Not going to do so much. Like, it's easier. I think it's faster to just use the formula. The formula is so much faster. Like, now, if you want to plot the point and do all of that, that's fine. Okay, so point 1 is 4 comma 5. and the second point is -1, -5. Okay, so first thing I would do here is I would label the points. This is x1, y1, x2, y2. That way you know what goes where. So the distance is going to be the square root of -1 minus 4 squared plus -5 minus 5 squared. So this is going to be the square root of two negatives make a more negative. So I owe 1, I owe 4, I'm going to owe 5 squared, okay? I owe 5, I owe 5, I'm going to owe 10 squared. Now, one thing you need to know is when I square a negative, I'm going to get a positive. So this is going to turn into 25, and this is going to turn into 10. 10 times 10, which is 100, right? And so this is going to turn into the square root of 125. And again, do you notice that there's no answer that says square root of 125? Because think about all the perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, right? 4 squared is 16, and 5 squared is 25. Okay, so notice that I have a perfect square that can come out, 25. So the distance is going to be 25 times 5 is 125. So this is the square root of 25, then the square root of 5, and the square root of 25 is 5 square root of 5. Okay? And that's it. Now, if you do it if you want to plot it, let's go ahead and go and plot it because you might want to do it that way. Let's go ahead and clear all, discard. So if you want to plot it over here in GeoGebra, you can just go parentheses 4 comma 5, and then you go parentheses -1 comma -5. And then you do a segment, you go to tools, you grab a segment, you connect the two dots. And if you want to get the distance, you see right here where it says, where is it? Oh, it's up here, right? Distance right here. So you just go like this, boom, click on this, click on that. And so my distance is 11.18, okay? And watch what I can do to get the 11.18. Watch this, guys. This is so awesome. 5, and then you type SQRT, or gotta put times SQRT, parentheses. Okay, let me do it again. Watch this. 5 times SQRT, parentheses. See how it turns into a square root? And then you put a 5. And look at that. Aren't they equal? You see how this is equal to that? Now you know that this has to be the answer choice. Does that make sense? So you could go answer choice by answer choice till you match it. Because look, if I try answer choice, what is it? Answer choice, let's try answer choice D, for example. If I were to try answer choice D, and answer choice D, what was it? Answer choice D is 75 squared root of 3, okay? So if I were to type in 75 times SQRT, open parentheses of 3, notice how that's terribly different. The answer is 129.9. So that's not an answer, okay? All right, so you get to do problem, let's go back to this one. You get to do problem 16, I'll do 17, okay? And this time I'll do it using GeoGebra real fast so you can see how it's done with using GeoGebra. So 17, P is 3 comma -5, and then Q is 5 -1, okay? So watch, I'm gonna go to GeoGebra real quick. Let's go to scene 1. Okay, so let me clear all, discard. Remember, we're in algebra.org calculator, okay? Watch this. I'm going to just type in parentheses, 3 comma negative 5, and then I'm going to do parentheses, 5 comma negative 1. Okay, then I'm going to go to tools. I'm going to draw a segment. Don't forget to draw a segment. Well, I mean, you could probably do it without a segment, but here it is. You see that? There's the answer, 4.47. I know that's my final answer. Now I'm going to go answer choice by answer choice till I figure it out. Okay? So if we go back to the assignment, we're going to go through answer choice A, then B, and all of a sudden, B is the one that works. Let me demonstrate. So B is 2 squared of 5, right? 2 times SQRT of 5. Oh, look at that. They match perfectly. 2 squared of 5. Okay? Aren't they exactly the same? That means the distance from here to here is that answer. You see? And you might, just to put it all together, let's wrap it up. Let's wrap it up. Let's make a point here. So if I put a dot right here, oops. Let's put a point right where they would be there, okay? Then if I put a segment and another segment here, notice how we have a right triangle. In the right triangle, we can do the Pythagorean theorem. So if I find the distance from here to here is obviously going to be 4, right? Okay, and then the distance from there to there is obviously 2, right? I hope everybody knows that. That's 4. Wish I could move this over. All right, that's 4 from here to here, and that's 2, right? So if we go back to our calculator, the Pythagorean theorem says that the distance between AB is going to be the square root of 4 squared, right-click, plus 2 squared. Okay? See how we get 2 squared of 5 as our answer? See, this is 4 going up. This is 2 going across. Notice how it gave us the 2 squared of 5. I hope you like it. All right, that concludes 17. Let's go to back to our sheet. So you do 18, I'll do number 19. Let me move number 19 up a little bit. We're almost done, guys. Okay, so number 19 says list the ordered pairs. Okay, this is like the simplest question ever. You just put them in parentheses, okay? So you know how we have a list like this, 4, then -9, then we have 5, and then we have -12, then we have 7, then we have -18, then we have 8, and then we have -21, right? All you gotta do is turn them into this, into ordered pairs. These are called ordered pairs. Points, if you will. Look at that. How easy is that? And what answer choice would you pick for number 19? Wouldn't you pick letter A? Absolutely, letter A. Okay? Hopefully you understand. And that's it for today, guys. You get to do number 20. Hope you have a wonderful weekend. We will see you soon. Thank you. Bye-bye.